This has been an exciting month and a half or 2 months for a Japanese mission, which has been orbiting a small asteroid for about the last 10 months. I think it got there in June of last year. And this is designed to collect samples of the surface, orbit the asteroid for about a year and a half, and do an up-close study of this small type of asteroid. So this is a close-up view from the spacecraft taken about 20 kilometers away from the asteroid. And it's a fascinating place. It's what they call a rubble pile. As you look at, you get closer and closer, there's boulders down to the resolution of the images. You see all the big ones here. When they get really close to the surface, it's still covered in rocks. It doesn't have a nice fluffy surface like the Mars surface we were looking at. And it's just what little bit of gravity a small object like that can exert. It keeps the body together. So I've shown this before, but this is a European, the Japanese have built some little rovers or small spacecraft that get deployed from the mothership, and the French are also involved, and so they made this scale drawing of the asteroid sitting in the middle of Paris, and it gives you an idea for how small it really is. It's about 1 kilometer in diameter, so 0.6 of a mile. So it'd fit nicely in City Park. It's a pretty small object. And so here's an artist's view of trying to collect a sample. This happened for the first time back in February. So they very slowly drop the distance, and then there's this horn that touches the surface, and when the sensors detect that it's at the surface, it fires a metal slug. It's sort of like a gun, fires out of the end of it. The spray of material gets caught up in a funnel inside this guy, and then it gets put into a canister, and eventually they will launch it back to the Earth. So this was the target that they chose for the first sample collection back in February. They're very clever the way they do this. They have 5 target markers on board. They're just little spheres about yay big, say grapefruit sized, and they're covered in reflective mirrors. And when you are in a position where the sun is over your shoulder, so you would be looking at the sun behind me if that was the case, and the mirrors reflect the sunlight back to the camera. So you have a really bright spot on the surface, and then as you come in with this geometry where you're sort of following the line between the sun and that bright point, and the spacecraft can guide itself to home in on that bright spot. So they can use that as a way to mark where they want to come down. And so here's a view of where they did the sample collection. There's the target marker, and they wanted to be just a little offset from that. And then this is the size of the spacecraft. So you can see why they're concerned. You've got all these big boulders around. If you came down and hit one of the solar panels with that boulder, you're likely going to have an accident and damage the spacecraft. So this is just a 3-dimensional model then of where they were targeting coming down. And this is a view from the mothership itself, and there's the shadow of the spacecraft being cast on the surface as it's coming in. So you can see the two solar panels and the body of the spacecraft. And here's a video from on board the spacecraft. There's that sample horn, and this is sped up by a factor of 20. There's where the slug gets fired, and they just touch for less than a second. And that blast happens. It loosens all sorts of material flying around, and they just back the spacecraft off to avoid getting covered with all the material. But the idea is, with that kind of activity, they should have been able to collect some of the material in their sample collectors inside the horn. And then this is a view after they withdrew. I think it's from about 200 meters off the surface. So there's the shadow of the spacecraft again. And this dark splat here is sort of surrounding where they took their sample. So it sprayed all that material out and left a dark mark behind. So that has worked. And then the next step that they've done is, this is a very clever spacecraft. They've got all sorts of little doodads on it to try different things. In many ways, it's just a technology demonstrator. So they have this device called the SCI, the Small Carry-On Impactor. And it's about the size of a cheesecake, say. At least a cheesecake that I would buy. And they get within about 500 meters of the surface. They drop this off, and at the same time they drop off a few minutes later, they drop off a little camera spacecraft that will look at the area that this thing is going to influence. And they've got a 40-minute timer on this to give the mothership time to move away. And this is slowly settling to the surface. When it gets about 100 meters above the surface, so a football field high, there's an explosive device inside this with about 10 pounds of plastic explosives. And let's see, I think I have a picture of that. So this is where this is the whole probe. This is where the explosives sit, and then on the bottom end of that, there's a copper plate that weighs about 2 kilograms, so 5 pounds. And when this explosion happens, it forces that plate out the open end, and it hits the surface at about 4,500 miles an hour, 2 kilometers a second. And that's enough to blast about a 10-meter diameter hole in the ground, they think. And so that's a 35-foot diameter crater that will get formed. And so the idea is, we know how much energy was involved in smacking the surface with that copper plate. And you can tell a whole lot about the subsurface structure and texture by how big the crater is that's left behind. If it's solid rock, it would be a smaller crater than if it's loose stuff that gets blown away. And so for this happened, well, sorry, I'm a little out of sequence here. I think it was the 5th of April is when they did the deployment. And during that time, the mothership moved to the far side of the asteroid and stayed there so that they could avoid any debris cloud that was given off from this. And they've slowly been moving their way back around to where they can see this area. And today, they've started descending back down above where the crater should be. And so they'll get some high-resolution images. But this, right about here in the center of the image, is where they were targeting. This is a view from the onboard camera, which has a flash on it. And so this is the impact, the small carry-on impactor, the SCI, after it was released from the mothership. And I think there's, let's see, I think I skipped a slide. No. So here we go, just looking down on the surface, and very slowly the SCI is drifting away from the mothership. And then the mothership starts to move off to the side. And this is just an artist's view of what the splat might have looked like, the impact itself. And so they were hoping to see something like that with this separate camera that they dropped off. And this is the view from that camera. And this is where the impact should have hit. And you see a splash. So they have high confidence that the explosion happened and the plate actually hit the surface. And so what they're doing today and tomorrow is slowly descending to the surface. This morning they started out about 20 kilometers above the surface. When I checked just before we came in, they're down to about 4 kilometers. They expect to get down to 20 or 30 meters, so 100 feet or so from the surface, and then they'll just stay there, take images, and then back off again. And once they know the lay of the land in this new crater, they may decide to descend and try to pick up a sample from inside the crater. And the purpose of that would be you've dug a hole in the ground, and you'd be able to sample, if you're lucky, sample material that is actually internal to the asteroid rather than sitting on the surface. And so that could tell you a lot more about how it's put together, and it avoids the issue of all the radiation damage that the surface material sees. So that's where we are right now. I expect by next month we'll have an update on this. We should have images of this new crater, and if they decide they're going to collect a sample, they probably will have done it within the next month. So we'll certainly do an update on that.